Good morning, Math 2. I want to share with you this morning for 1.5 just some letters that the book uses and kind of universally now. These letters are used to identify different types of real numbers. So I wanted to show these to you, and then I want to do a little table for you on the little diagram on the board that you'll need for when you do your homework, okay? So this is a Z, and Z, I know, I have no idea why they've made this Z, but Z is integers, okay? So kind of process that. So integers are numbers that are positive and negative whole numbers. So they come out even. There's no decimals, there's no fractions. So those are positive and negative whole numbers. That's integers. So that's a Z. Okay, there's that. This is R. R is just everything, except for irrational. Irrationals kind of get kicked out. Okay, but R is everything. Okay, so that's R. And then this is Q. Q is, if you'll remember that the word in a dividing problem is quotient. Can you remember that? The answer in a dividing problem is quotient. That helps me remember Q. Q is for rationals. So rationals are numbers that end, okay? That end or have the same pattern, okay? Any number that ends. A repeating number is also considered, like 0.3 repeating is also considered rational, okay? 0.217, all right? 3/4, all right? That's considered rational. And this is including whole numbers too, and negatives. Basically, rational numbers are everything if they end, if they terminate. Okay, so that's a larger set is Q. That's your rationals. All right, and then of course there's the irrationals, and we know what irrationals are. Irrationals are those weirdos that just, they don't fit anywhere. They're like out in the universe. Pi is one of those, right? Pi 3.14, blah, 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 right? That's considered irrational. If you put the square root of 7 into your calculator, irrational. It never, you'll see, it'll keep on your calculator. It'll go until the calculator ends, and then there's nothing left. So it just keeps going after that. So I wanted to show you the diagram. You're going to have to do this in homework. Okay, I'm going to put it up high so you can see it. So it's kind of like the donut thing, right? So you have real numbers. Now remember, real numbers is everything. Rational, irrational. Real numbers is everything. So that would be where your R would go here, and that's everything. And then the large circle would then be your Q, and that's all the numbers, remember, rational, that end. They end, they terminate. 0.24, okay? 5/4. 5/4 is a fraction, but when you divide it, it ends. 1.25, okay? All your positive and negative whole numbers are in there too. Basically, the numbers that we use every day that work are considered rational numbers, and that's your Q. Then on the inside of that, kind of like a donut, would be your Z. See, those are included inside the rationals, but they're special kind of rationals because Z is your integers, and those are the ones that are positive and negative whole numbers. There's no fractions or decimals. I hope that's clear. The only other weirdos that we mentioned earlier is the irrationals, and they don't fit in the circles. They come out here. So pi, square root of 7, you know, things like that that are just strange. And they don't end on the calculator when you divide them, okay? So review real quick. We've got real numbers. That's everything in the universe. We have rationals, which is Q. The letter is Q. And those are basically all the numbers that we use that end and terminate, that we use every day: fractions, decimals, positives, and negatives. And then inside of that special is Z, your integers, and those are the ones that have no fractions or decimals. They're positive and negative whole numbers. And then outside the circles, kind of in the universe here, within the real number universe, is the irrationals. Okay? Got that? So this is your poster, hopefully, not poster. This is your video. Hopefully you're watching it and preparing for class on either Tuesday or Wednesday, whenever you have me, for 1.5. Okay? Thank you.